Welcome to solverfy.
Okay, so this question asks you to actually calculate the empirical formula of this compound. So we know it's a compound contains carbon, hydrogen, and oxide. And when you combust it, you react with oxygen to form carbon dioxide and water. From this, we know that the carbon is directly comes from the compound, and the hydrogen is also directly coming from the compound. However, for oxygen, some of them comes from the oxygen gas, some of them comes from the compound. So the hard part is how to know how much oxygen comes from the compound. Here we can actually find out. So the first thing all you need to do is to calculate how many moles of the compound how many moles of the carbon inside the compound. So it says right, for the carbon dioxide, when do a combustion, you generate 0.403 grams. From this, what we know is we can actually know the moles of the carbon generated is equal to the moles of the carbon dioxide. It should be a 1-to-1 ratio, right? If you look at the formula, which equals to the mass of the carbon dioxide over the mole mass of the carbon dioxide. And this is equals to 0.403 over 44 and equals to around 0.916 more. And from this, we can also know the mass of the carbon is simply just equals to the N carbon times the mole mass of the carbon, which is simply 0.0916 times 12. It's equals to around point it's equals to around actually 0.1092 grams of the carbon. Sorry, here's double zero here. Yeah, this is the answer. And same for the water. We know that there are 0.166 grams of water formed. So we can actually know the moles of the hydrogen were actually doubles the moles of the water, because each water has 2 hydrogen, and equals to the mass of the water 0.166 over the water 2 times the water is 18, and this equals to around 0.0183 more. And same, we can calculate the mass of the hydrogen here, which simply equals to around, because the mass of the hydrogen is 1, so it's equals to 0.0183 grams. And now, things become easy actually we can actually calculate the mass of the oxygen inside the molecule. It's simply just use total mass minus mass of the carbon minus mass of the hydrogen, which equals to 0.165 minus 0.10992 minus 0.0183. And this actually equals to around 0.03675 grams. And using that, we can calculate the moles of the oxygen. Simply use mass of the oxygen over the mole mass of the oxygen, which is 0.03675 over, for more oxygen, more mass of oxygen, 16, right? And this is equals to 0.00 229.697 moles of the oxygen. So now we can actually know the answer, right? The moles of the carbon, the over ratio of the moles of hydrogen, the ratio of the more oxygen, simply equals to those numbers: 0.00916, 0.00916, 0.083, and 0.02297. So this probably is so this actually equals to 8 versus 1, and this versus 4. So this is the formula. So we know it becomes C4H8 and O. And then it says the mole mass is 144 grams per mole. So what's the mole mass of this one? It's equals to 4 times 12 plus 8 plus 16. And this equals to actually 72. So it's half, which means the double C4H8O and will equals to 144. So the real formula should be C8H16O2. And this is the answer.